Welcome everyone to the Exploring Algebra on Polypad webinar from Mathagon with our guest, Dr. Nikki Newton. My name is David Porras. I am the Director of Content at Mathagon. I'm also a full-time 7th grade math teacher outside of Massachusetts. Dr. Nikki Newton is an educational consultant who works with schools and districts around the country on elementary math curriculum, including best practices, guided math and math centers, as well as curriculum mapping. She has taught elementary school, middle school, and graduate school, having spent several years as a bilingual teacher and staff developer. She has an extensive background in sheltered instruction and English language learner strategies. And you can learn a lot more about Dr. Newton at her website, drnewton.com. I think everyone is muted, but let me just make sure. All right, so here is her website. I'll put her website in the chat, but I'm going to jump in just by doing a quick overview and tour of Mathagon, and then I'll turn it over to Dr. Newton, who is going to start off the webinar. So we are here tonight to explore Mathagon. I think you can see my screen up here. And let me just change my mode for 1 sec. Awesome. So here I am at mathagon.org. Mathagon is free for teachers and students all around the world. So everything that we are going to share tonight is totally free. Mathagon has courses, activities, all sorts of things for teachers, but we're going to be spending the majority of the time on Polypad, which we describe as an open canvas for exploring and creating mathematics. Polypad is our virtual manipulatives. I just want to give you a quick tour of some of the things on Polypad that after this webinar, you might want to go back and learn more. On the left here are the tiles. We have a number of categories of tiles. And you can see as I expand the first section in geometry, there's a number of categories of tiles in geometry, polygons and pentominoes and tetrominoes and so on. Next to each category, there's a question mark. And if you click on the question mark, it'll bring you to an instruction on all of the tools in that category. So if you want to go explore more and you're like, how does that work again? Or I'm in the numbers category, how do the number cards work? You can click on the instructions and it'll take you to a whole tutorial on the instructions. The other place to go learn more is I'm in a teacher account right now. So I'm going to click on For Teachers, but you can also get there by just going to mathagon.org/teachers. So it's on the screen here, mathagon.org/teachers. It's free to make an account. If you have a student account and you want to switch it to a teacher account, you can go to account settings and then you can change the account type here. And if you have a teacher account, For Teachers will pop up. You can go watch all of our past webinars and you can learn more about Mathagon at the secondary level, the elementary level, exploring probability, exploring data science, all sorts of webinars. We have tutorial videos, really some wonderful tools to use Polypad as a teacher. You can make classes, you can share a Polypad with students, you can share it to Google Classroom, you can do the question builder tool. We're not going to talk a lot about those tonight, but you can go explore. And then finally, there's a whole page of lesson plans, over 100 games, puzzles, activities, lesson plans to explore. So that's a really fast overview of Polypad and Mathagon. Here is Dr. Nikki Newton's website. So you can go to drnikkynewton.com and learn more about her. And here we are on Polypad. So that is a really quick introduction. Again, welcome everyone. We are excited that you're going to be here the first 20 minutes or so. Nikki's going to be doing exploring algebra at the elementary level, kind of K to 2. And then I'll jump in after that and talk more about upper elementary and middle school. So again, welcome. Really glad you're here. I'm going to stop sharing and allow.
And we need people to actually sign on and get on because I'm going to have people do the tool, play with the tools.
Yes, I'm going to put that in the chat. There's a link I'm going to put in the chat, and you can go to mathagon.org is the site. It is free, so you don't need to make an account to go explore with Nikki. But if you want to make an account, you can do that as well. All right, Nikki, take it away. Really excited to have you here. It's an honor to have you join us. I will mute myself and jump in as.
Thank you so much. I am honored to be here with you. Thank you for inviting me. I'm just going to do a quick overview, like an intro into some thinking about developing algebraic thinking in the primary grades and, in elementary grades. and then we're going to just explore some activities. So Blatton, who has done, a tremendous amount of work on developing elementary algebraic thinking, says that algebraic thinking empowers children. It's learnable. All children can learn to think algebraically. And Kieran says that algebraic reasoning is a gatekeeper and for students in their efforts to progress in mathematics and science. And an early introduction gives all students more opportunities in later mathematics and career choices. And it may serve to support the transition to formal algebra in the secondary grades, which research has shown to be very difficult and traumatic, if I might add, for most students. Carrere says that students have a lot of trouble when encountering formal algebra, but that most of these difficulties can be traced back to missed opportunities and notions originated in the early mathematics instruction. I see David nodding his head. A lot of middle school teachers say that. My friend, one of my good friends, she's a middle school teacher. She's always saying, I have to tell the kid that idea has expired. That is no more. It does not work now. Because we teach them these things in the primary and elementary grades that just don't hold water when they get up there. So I think that Kieran really hits it, right where it is when he says that we have to undo all this stuff that happened down there. So hopefully we can get it better. NCTM has defined algebra in this way. They say that it's about understanding patterns, relations, and functions, that is representing and analyzing mathematical situations and structures using algebraic symbols, that it's using mathematical models to represent and understand quantitative relationships, and it's about analyzing change in various contexts. So we do all of this stuff in the primary grades. I think we just have to recognize that we're doing that. And what a lot of people say is algebraify, right, our curriculum, right? And I love that term, it's a research term, to algebraify what we're doing so that we really can help our students be prepared. So tonight, in some of the examples I'm going to give you, I'm going to really look at representing and analyzing mathematical situations and also, using mathematical models. The focus in the primary grades is not to teach kids formal algebra, right? That's not what we're going for. But we're really trying to get kids to do explorations and investigations and then talk about what they're noticing. And I think that's the beauty of the tools, because it gives you something to talk about, right? To talk about your thinking. And so Blatton says that as teachers, we have to develop algebra eyes and ears. And I love that, right? That we have to be able to look at a problem and know how to algebraify that problem, how to make the known unknown, right? Algebraifying the K-12 curriculum will transform algebra from an engine of inequity to an engine of mathematical power. I love that because I think it's so true. If our kids could actually develop that algebraic thinking, it's like a superpower. Right. So with that, we are going to jump into some problems. And so we have a link for you guys where you'd be able to get back to these problems later on if you want to go back and look at them. I've set them up. There's looking at 7, reading equations. This is the model. And true, false, and making a known unknown. So one of the things that, I'm going to do this one first.
Yeah, great. I just want to jump in. I put a link in the chat to all of these polypads. One feature that we're really excited is coming soon is the ability to create a public folder of polypads. So what Nikki would be able to do down the road is put all of these in one folder, save that as a folder, call it Algebra Webinar, and just share the link to that folder, and you can access them all in Mathagon. So that's coming soon. But for now, you can go to the PDF that I dropped in the chat, and you can click on any of the ones that Nikki's talking about.
Okay. Well, One of the things that I think is really important that we do with kids in terms of representing the math that we're doing is so often we give kids the problem. And we say, they talk about the difference between contextualizing and decontextualizing. So you're either going, with little people, we talk about going from numbers to words or words to numbers. And we tend to go from words to numbers. We read the word problem and then we say, now what are the numbers? Right. But the other thing that we should be doing just as much, and this comes under the reasoning practice, is we should be going from numbers to words. We give the kids the numbers, we give the kids the models, and we ask them, what does that represent? And you get the most creative, brilliant answers. So I want you guys to play around with that idea a little bit. I put up several models because they have so many cool things up here. So if you go to Tiles, and David, jump in at any point. Okay. They have so many cool things. So you can go to Tiles and say, if I'm in the upper elementary grades, I'll go to the fraction circles and I'll pull out those and play with those, right? And I'll just put this up here and ask the kids, what's the story? Right? Or I could go to the numbers and they have these Cuisinart-ish type bars. I mean, in Montessori, they have bars like this too, but they're not color coded necessarily. But you guys also, and remind me, David, you can change these so they're the actual Cuisinart bar colors, right? Where can we do that?
So if you go to the right under the gear, on the toolbar on the right and click on settings right there. Yep.
Yes, on settings.
And you can show the alternate tile colors, which is
alternate tile colors, right?
And that's
so if I want
colors.
Yeah, so if I wanted to pull these up as Cuisinart rods, if close to Cuisinart rods, I could do that. And so I could put that up there and just ask the kids, what's the story? Right. And I think that really gets kids, or I could do this. I could say, what's the story? Right. This could be a comparison story. Ron ran 10 miles. His brother ran 2 miles less than he did. His sister ran 1 more mile than his brother. I mean, it can be all kinds of things. It doesn't have to be that story. And then I could do this, right? This could be a multiplication story, or it could be a division story. And I use the number tiles. I love the number tiles. And then I could do this, right? And this goes down, you can get the fractions out and, go to the fraction bars and just put that together and just ask the kids, what's the story? What happened? What is this telling us? What do these numbers mean? Right. And I love it because, again, it's, low floor, high ceiling. Everybody can do this. These are visuals and everybody can have access to it. And they're going to tell stories at their entry point. What you know what I mean? Somebody's going to tell an easier story. Somebody's going to tell a more complex story. Somebody will tell a 1-step story. Somebody will tell a 2-step story. Somebody will tell a multi-step story. So I love this activity for developing algebraic thinking, right? Putting the models up. And then there's also these cool little circles. Now, where did I get these little circles from, David? I have to remember.
Those were under the dot,
and they're a number, and they are dot arrangements, right? So those are cool. And watch this, you can take them out. So that's fun, right? But I mean, you can do a whole bunch of stuff with this. I mean, just for little folks, you could do supertizing too, but we're not talking about that. But you can put this up here, right? And say, what's the story? Right. So that's the first thing I want to talk about is what's the story. And I wanted to give you guys just a chance to go around and look at some of the models and think about your class. Think about if you did this tomorrow, right? Think about what it means not to just tell stories, but to get kids to tell the stories by you putting the model up.
Yeah, I think that's such a cool idea. And I was also thinking that as kids get more comfortable with the tools, the students in class could make a picture with the manipulatives, and they could share it
Absolutely.
with their classmates, and their classmates could write stories for each other's pictures, right? So the kids are
Absolutely.
both doing the making of the model, and then they are making the story for their classmates' model. Could be kind of fun. This
Absolutely.
is something that I haven't done in middle school, and I think is a great invitation for kids at all, at all levels, to just, here's a picture, go write a story that goes with this visual representation. Such a cool idea.
Yes. Yeah. So this is the model, and I really like that. And then there's reading equations. And so I'm going to go, I'm going to say,
You have to hit the
I was going to
discard.
say,
Yeah.
oh, because I had made some changes in there. All right. So I'm going to go to this now. My math crush is Marion Smalls, hands down. So I read everything Marion Smalls writes. I just got to write the foreword for her new book on high school open question stuff. She wrote it with Lynn, I think. I'm not for sure who the co-writer was, but I love anything Marion Smalls does because she's just brilliant. She wrote a book on algebraic thinking, 2014, looking at algebraic thinking K8. And so this is, I want to do a section on her. She says, students benefit by reading equations or having equations read to them in meaningful ways. Too often in the primary grades, we rush to what's the answer. We just want to do some arithmetic, some calculations. And we don't think about what is this asking us to do? So Marion Smalls really says basically that we should read the equation in a lot of different ways and read it in a way that implicates what's happening. So here we say, we could read this equation right here. Let me make it bigger. So for those of us that need it to be bigger, although we can read what equals 40 minus 4, we could also say, how much more is 40 than 4? Or we could say, how much is left if 4 is removed from 40? I mean, that is just like powerful, right? Or how much do I have to add to 4 to get up to 40? And so looking at that and thinking about that, oh wait, I don't want to go smaller now. You can use, there's so much stuff that you can use in terms of the tools. And so I wanted to give you guys, I'm going to give you a minute just to play around. I want you to play around with the tools and think about these questions. Like, so what tools might you use to get kids? If you said, how much more is 40 than 4? What could you get kids to do? And I was playing around with the number tiles, because I was thinking you could take 40, right? And the question is, how much more is 40 than 4? And then I was thinking, one of the things that you could do is just cover up 4. And then you would see how many more you had. Right? So we could see that 40 is 36 more than 4. Right. But you can do that on I like these little cool 100 grids that you can pull out, because we can do that up here by looking at how much more is 40 than 4 and getting kids to figure that out on the 100 grid as well. So using the tools to get kids to unpack, but asking the equation, turning that equation right into something of conversation, not just what equals 40, right? And so in thinking about that, I made a couple of ones. Let's discard that. I made another one. Marion Small says, so giving the kids 20 minus 12 and saying, what is the story of 20 minus 12? So I want everybody in the chat, write a story that fits this sentence. Everybody write a story that fits this sentence. And then I want you to go to the tools and figure out how you could solve what you have written. And then I'm going to give you some more information. So I'll give you a minute to do that. Everybody in the chat should write a story that goes with that equation. How can we think about that equation? David, do you see some stories coming up?
Not yet, but I'm sure they're being.
Not yet.
Not yet. I'm sure they're coming. Everyone's allowed to chat. Yeah, awesome. And then you can go on the PolyPad and play around with the tools. This the PolyPad that you open, anything that you're doing on it is on your copy of it, right? And if you want to save it, you could go up to File and hit Save a Copy, and that'll save a copy of that into your account if you're logged in with an account. If you're not logged in with an account and you're just playing around, then it won't save your work, but you can still go play and explore all the tools. How much is 20 minus 12? Yeah, thanks, Erica, for sharing that. This afternoon it was 20 degrees and now it's 12. How much did the temp drop? Thank you.
That's a great question.
Make sure if you want to send a message to everyone, not just me, but there were a couple that were just sent to me that I could read. There we go. We got some ones coming in.
Oh, good.
Is a fun story. Chad had 20 M&Ms. Mrs. C, sorry. She gave 12 of them to her friend. How many did she keep for herself? Awesome.
So these are some of the tools that I look at this. This is cool. You can take this out and you can stretch this out to, well, I'm going to change my width so that I can, oh, wait, I didn't want to go to 11. So I could change that and bring out 20. And this is the cool thing about this. You can flip this, right? And so now I can figure it out on a vertical number line, which we kids, you know, we don't do these a lot in the States until the upper grades. Kids need to see ladders and lines, right? So I love this, that you can do that. You can have a lot of fun with that. But I would also pull out the number bars. I'd also pull out, you know, I'd pull out the number cards. And I love these. These are the Numicons. Nobody else really has these Numicons. And the Numicons are really great because, you know, you can do all kinds of stuff. If that was the 20, then this would be 12. So we could see that there's 8, you know, depending on what your question was.
You could change the color of the first 10 that you put on top if you wanted to.
Oh, okay. Tell me how to do that.
On the bottom, there's the green color picker.
Yeah, so make that. Yeah, so I could change that to that. I could also go and change that and right. And then yeah, so that's perfect. So then I could see. Yeah. So
awesome.
This is the questions that Small says we can ask about that, along with what you guys already put in there. I had 20 cookies and we ate 12. How many are left? So that's like, you know, a typical question. It's a great question. Or my brother is 20 years old and my sister is 12. How much older is my brother than my sister? We need to be doing these kinds of questions as well in the primary grades. Or I have $12 already, but I need more to buy a game that's 20. How much do I need? So this idea that we're not just rushing to the answer, but that we are actually getting kids to think is super, super important. So there's one last problem I want to share, and then I'm going to turn the whole thing over to David. This last question is, students should realize that the equation 24 plus what equals 90 can be asked as, how much more is 90 than 24? Or what do we need to add to 90 to get 24? I mean, to add to 24 to get 90. Or how much more do we need to add to 24 to get 90? Very similar questions here. Or what number is 24 less than 90? And you can use this again, the 100, but then they've also got the scales. And I know Dave is going to talk a lot about the scales, but take a question like this, and the kids can use, you go to the tiles, and you go down here to the number cards, and I use the number cards, but there's David's going to tell you about the other stuff you can use. And I just put 24 here, and I put 90 here. Right? And I would let the kids figure out how to do it. I wouldn't do it, but I'm just telling you guys how they might do it. They might put 90 here and 24 here, because we're saying, what do we need to add to 24? Right? And then this helps us too, because we could say, well, if we were at 24, we could jump 6 and get to 30. And then we would go down to 60. We would go down 60 to get to 90. And then they can see that it balances. So I love these tools. I think they're really fun. I think they have a lot of possibility. And I think they really can help us to get kids to think algebraically. So just so that you know, there's some stuff around true, false that I didn't even get to, but they're up there for you to go and read, because that's really important in developing algebraic thinking. And then there's a problem making a known unknown. So all the links are in there for you. So I hope this has been helpful.
Yeah.
And David, I am turning it over to you.
Awesome. Thank you, Nikki. That was awesome. Let's show some love for Dr. Nikki in the chat. That was great. She's going to stay with us, and hopefully as much as I jumped in, she'll feel free to jump in as well. But I think that last example showed to me the power, I think, of Polypad is being able to have multiple tools on the canvas at the same time. So just that last example with the balance scale and the number cards and the grid, and they all work together at the same time, I think is a really helpful way for kids to make meaning of mathematics. So I'm going to extend maybe upper elementary, middle school, and then get into some high school. We'll have time, the last 10 minutes, any questions that you have about what we've talked about tonight, feel free to ask those towards the end. I'm going to go to our teacher page again, which is mathgon.org/teachers. And I'm going to go to our lesson plan page. And our lesson plan page, you can also just get to at mathgon.org/tasks, which I'll put in the chat. And the first thing I'm going to do is a fun warm up that I do a couple times a week in class. I've done on my webinars. I know there's some familiar faces, so you're here with me again. And you've seen this warm up, but I think it's fun to do. It's called What Two Cards? It's under class openers and math talks, again at mathgon.org/tasks. There's a growing list of class openers and math talks. If you have some you'd want to add to this list, feel free to let me know at David Porras on Twitter, and you can send an email through the Eventbrite page as well. But let's play What Two Cards? And here you can see on the screen is a balance scale. You can see I have the cards that are numbered 1 through 10, and I have some dice. So one thing, we added some updates to Polypad today. One thing that was added is sound effects. So I have sound effects turned on. Let me make sure my volume is all up. And one of the sound effects, here are the cards. We have the cards numbered 1 through 10. I'm going to stack the cards. So now they're in a stack of 10, and I'm going to shuffle. And you might hear a shuffle sound effect coming from my computer. So I'm shuffling the cards. I can keep doing it, but I'm going to turn the cards over. And now I'm going to draw the first card off the top. We don't know what that is. And draw the second card off the top. So I have 2 cards on the balance scale. If you want to play along, feel free to drop in the chat what do you think those 2 cards are. Some cards 1 through 10. I haven't given you a lot of information yet, but you could play along and see if you get the 2 cards correct. And now I'll put 2 of the dice. So under probability and data, that's where I got the playing cards. And then under coin, dice, and spinners, there are the dice. I'm going to put these on the other side of the scale. And as I let go, we'll see what happens. And we can see those 2 cards are heavier than the 5 and the 2. So if I was doing this in middle school, maybe I could say that 7 might be less than, or sorry, the 2 cards, we'll call them A plus B, is heavier than 7. If I'm representing that right algebraically after a full day of teaching. I just saw in the chat, there was a question about the task. This is class openers and number talks, and it's called What Two Cards? Thanks, Chad. And so I now know that they're bigger than 7, but what I can do if I click and drag on the 2 dice and I spin them or I roll them, I get more information, right? And so now I have 7, right? Not helpful because we already had 7, but let me roll them again. And now I have 6, not helpful, still not helpful. Let's see, more than 6. I'm gonna add a 3rd dice in the interest of time. And let's see how that compares. Oh, it's still heavier than 10. So I could cover up all these numbers. If I wanted to take this and change it with my students, I could say we're currently more than 10 now. Let's keep going. You can update your guesses in the chat if you want. Let me randomize them all again. Oh, what's that? 6 and 5 is 11. I'll do it one more time. And in the interest of time, I want to move on here. That's 12. Let me show you the first card. Oh, there's a 10. So maybe now I'd keep the 10 up here and let's make a 14. I just copied that 2 with the C button on my keyboard. So the C button makes copies. Let's see. Let's just see if we can figure out what this card is. Oh, it's, of course, it's more than 20 because it was a 10 and a 9. As this is going on in class, students are thinking about how the 2 sides of the scale kind of balance out, right? I'm just going to show you this card in the interest of moving on. There's a 6. It was 16, right? And yes, you could graph the inequality on a number line as well. I'm kind of doing it here with the fraction bars to cover up, and I could show that these are going up and down as we go. But I want to slow down and really talk about the power of this balance scale, because what's great about the balance scale here, now I'm just going to kind of play from scratch. I'm going to go to algebra and find the balance scale and put this on. Again, this webinar is being recorded, so if I'm bouncing around and you want to go watch it later, you certainly can. All of the tools, all of the number tools work on the balance scale. So I can put a 10 over here, and then I could go, let me turn on the numbers. I'm going to show the number labels. I could do a 4 on this side and maybe balance it with a 6. Ooh, I didn't get my 6. So there's a 6 that balances. Let's put a 7 over here, and then go to the number cards and maybe put a 7 over here, right? And then I could take a prime factor circle. There's the prime factor circle of 10. And then I could take a dot arrangement of 11 and so on, right? All of these things work seamlessly with each other on the balance scale. I think I need a 1 here to balance it. And so there's all sorts of great activities that you can do with younger students on just playing around with numbers and different representations of numbers to balance those. The other thing that is really powerful, go ahead, Nikki. Yeah, you want to jump in?
No, I love it. I love it.
Yeah. So this is I just want to share with you under the algebra webinar how you can assign a value to an object. So here's my balance scale. I want to show you where I got all these objects on the canvas. This, I'll share it with you, but there's really not much to it. I'll put this in the chat just in case you want to pull it up. But let me show you where I got all these things on the canvas. So under algebra, there are a bunch of algebra tiles. So I put an X tile on the canvas and a negative X squared tile. And then there are, under the balance scale, there are these objects, you know, the plus objects and the weight and the heart. So I got those right from here on the balance scale. And then under geometry, under polygons, I pulled out a square and a triangle and a pentagon. And then I went online, and I like Beagle, so I screenshotted a picture of a beagle and I dragged it onto the canvas. And then I found a picture of a smiley emoji and dragged that onto the canvas as well. There is a button at the bottom where you can upload an image. You also can just drag an image from your desktop onto the canvas. And what I think is so awesome, all of these things I have on the screen and more can be assigned a value with the balance scale. So if I want to assign this weight, it starts with a default of 1, I think. But if I want to assign this a value of 5, I can go to the number cards and put a 5 here. It didn't balance, so that heart might be on there by mistake. You can see it's unbalanced. If I click on the balance scale on the fulcrum here, one of the options at the bottom says balance. So as soon as I click balance, Polypad on this canvas that I've saved at this link, anytime now that I use the weight, it has a value of 5. So I could know here that that has a value of 5. I could take the beagle, and if I want the beagle to have a value of 12, I put the 7 on the 5, it makes 12, and I balance it. Now that beagle has a value of 12, right? And any of these things I can assign a value to. So I could assign, you know, the square is 5 and the triangle is 7. I could tell kids, go build a shape and find the cost of that shape and put it on the balance scale and see. But I was having fun with this. So one that I prepared that I want to show is like, I gave this to my son in 6th grade who's never dealt with system of equations before. I'll put this link in the chat as well because it's not up for publication yet. And I just told him, I said, go find the value of the smiley face and the beagle. And he started playing around. I obviously never mentioned like system of equations or anything. And he just did the following. He said, well, he saw that 2 smiley faces and a dog is 36. So he took 2 smiley faces and a dog, a beagle, and pulled that off. And then then he copied the 36 and put that over here, and it stayed balanced. That was pretty cool. And then I think well, you know, he's my son and I'm the head of content at Mathicon. So he's played around on Polypad before, and he knew that he could go to the number cards. He kind of wanted to move the 36 over here, but obviously that's not going to stay balanced because we're taking 36 off this side and moving it over here. So he went to the number cards and he typed in a negative 36 and put a negative 36 on each side of the scale, because I've done this enough with him that he knew that makes a 0 here. But what I love about this is the idea of when we're maintaining equality on an equation, to subtract 36 off each side, we're actually adding on that negative number. And then it makes the 0, and it shows me that I've made a 0, right? So if I want to actually get rid of that, I have to go and take it off. And now this is 29. One option here that I have clicked is the merge number tiles options. So as I put the number cards on top of each other, they are merging to find 29. So now I know that a beagle and a smiley face is 29. So I could take these off and copy the 29 and put it over here, right? And then do the same thing with negative 29 and put a negative 29 over here to make a 0 and put a negative 29 over here. We found the smiley face is 7, and that must mean the beagle is 22. I could go on and go from there. So I think like just a nice playful introduction to balancing things with dogs and smiley faces. Of course, we can extend that with students. So the number value doesn't matter. It's just that it's yeah. So, you know, here it's balanced if I'm understanding what your question is. If you want to balance it, right? So if I wanted to balance it and I want to assign a value to an object, I put the heart on the scale. And if I want that to be like 22, I can type in 22 and put that on the scale. It's not balanced yet, but if I click on the scale here and then I click balance, now it's assigned the value of 22 to that heart. So maybe I'm answering your question, but we can keep doing it as well. The other thing we just added today, which is really exciting, I've done this in middle school a lot, and we often have the values of things, I'll set them as fractions or decimals. So the answer to the equation isn't obvious for students, and I want them to have to go use the tools to find the answer. And for a while, if I wanted this heart to be like 7 2/3, I had to do the following. I had to go 7, and then I had to go to fractions and put on the 2/3 here. And the 2/3 kind of doesn't fit on the scale. It fits, but it's like I could split them and I could pull them apart and make the 2/3. So now if I want the heart to have a value of 7 2/3, now I click balance, and now it has a value of 7 2/3. But what just got released today on Polypad is the following. Let me copy the scale. The other way to get a fraction or a decimal value, you can just use the equation editor tool. And if I type in like 5/7, that now works on the balance scale. And so if I want this heart to have a value of 5/7 and I click balance, now that has a value of 5/7. It changed it up here because now it's 5/7, no longer 7 2/3. You can also see it's showing me underneath it in gray what 5/7 is as a decimal. If I don't want my students to see that, or if they don't want to see it, under settings, I can click, I can turn off evaluate equations. So those of you that have played around with Polypad a lot before, this is a new feature where an equation works on the balance scale, and you can decide if you want students to see the evaluate equations or not mode. But let me keep going. I know there are some questions in the chat. I think I will answer those in my next tasks. I'm going to go back again to mathicon.org/tasks. I'm going to go to balance scale polypads. I have one that I just want to show you that I think is a really nice feature of how to use the balance scale. So there's a whole bunch here you can go and explore. Here's an equation that I made that has x's and negative x's. And this is one that my students were like, immediately did not know what the answer was. Yeah, I got the 5/7 by the equation button at the bottom. So I I clicked on equation here, and then I clicked on the canvas, and I can just type 5 divided by 7, or I could do fraction, do the equation, and do fraction, and then do 5 divided by 7, right? And get a fraction that way. Cool. But here, if I want to find the value of this, right, I could think about putting the number cards on each side. I could put a 48 on each side. Again, what are some moves that like maintain equality? Can we put the same number on each side of equation? Of course we can. And there's the 0, right? And now I kind of want to get these over here, but that's not going to keep it balanced, right? So what do we need to add on each side to make a 0 here? Well, now I can play around with the algebra tiles and get 2 of them. So I'll put on one algebra tile and another algebra tile, but to keep it balanced, I have to put 2 of the X's over here. All right, nice, now it's balanced. And now when I put these on top of each other, just like the numbers make a 0, these also make a 0. So those algebra tiles come together to make those zeros. I can get rid of them and then find the value of 1x if I wanted to. So I could spend a whole hour on the balance scale, but I want to show you a bunch of other stuff in the algebra section that is not related necessarily to the balance scale. So I'm going to keep moving on, and I will stay on at the end answering questions as long as you would like me to. So I'm going to go to a new polypad. I can just at the top, I can click on polypad, and I want to show you our ability to make graphs. So I'm just going to type in an equation. I don't know, I'll do y equals 2x plus 7. I'll make it a little bit bigger here. And then under tools and axes, I'm going to put on a coordinate system. So I'll put a coordinate system on the canvas. No graph yet, but you can see when I click on the equation, this blue little triangle comes up. It's kind of like a handle here. And as I move this around, if I attach it to the coordinate system, it graphs that line. I can change the scale of these if I wanted to. Let me count by 5s. So now I'm up by 5. I can make this purple if I wanted to. I could change the color of it, right? So that's fun. You could do, all sorts of graphs. I could make this 2x squared by adding an exponent here. There's a parabola. I'm gonna get rid of it for now. But all sorts of options. Ooh, I need to get rid of the exponent. There we go, 2x plus 7. But what also came out today, which is really exciting, brand new, you're getting like just released this afternoon, is sliders and variables. So it says new here. So I'm going to add a variable onto the canvas. That's b. So it says b equals 0. As I hit play here, you can see the value of b is like moving back and forth. I could have my range of b go from -20 to 20 if I wanted to. I could have it loop where it's going to go to the end and then come back around if I wanted to. I could have it bounce back and forth. But as I'm doing this, nothing's really happening because I haven't used the b anywhere. So if I go to my equation, and instead of a 7, if I make this 7 a b, then the graph is moving as b is moving, which is a really nice feature. There's certainly other programs have these sliders and graphs as well, but to be able to incorporate it with all the tools we have on Polypad, I think adds some value as well. And then if I want to, let's pause this and put one on. Maybe I'll do a is also going from -20 to 20. Right? And then I can make this, as opposed to multiplying by 2, I could multiply by a. The one thing that we need to fix in the equation editor, implied multiplication is not working yet. So ax will not be recognized as a times x yet. So I need to do the star or the asterisk above the 8 to show that multiplication. And now as I hit play, we can see the slope of the line is changing back and forth, right? So all sorts of really great explorations can be done with these sliders. Again, just came out today, so just like scratching the surface of what could be done here with these sliders. I can make this a squared, and as we push play, the shape of the parabola is changing, which is really fun. And then I can push play up here, and then that's going up and down at the same time. And of course, we could play them at the same time. It's super fun, right? So let's see what happens to the line while they're playing at the same time. All sorts of great movement is going on with those sliders. So, whoop, and you can change the speed of them. I can make the B going much faster if I wanted it to than the A. So now as I play that, that's going to go faster, right? And so just like kids, I think will have a great time playing with this, as well as exploring, more importantly, what happens as you change the values of those things. Awesome. So sliders are really fun. Let me talk about another use of the algebra tiles. How did the blue arrow show? Yes, great question. When you click on the equation, right? So here when I put in an equation, the blue arrow appears when I click on that equation box. You just have to make sure that it's not a text box that you're using, that it's a equation box, right? So that equation box went from there. Super fun. All right, let me do an algebra tile example and then we will open it up to questions. I just want to do one example of like completing the square here. So let me go to a new polypad. I'm not going to spend time now like talking about why students might need to complete the square. We could spend a whole webinar on that, but I'm just going to take the expression x squared plus 8x plus 7. And if I build out an algebra tiles, let me go to the algebra section, and here's an x squared and an 8x, 1. I'm going to copy them with the C button on my keyboard. What's that? 4, 5, 6, 7, 8. There's 8 x's, and then I need 7. So let me get the 7 over here. 1, 2, 3, 4, 5, 6, 7. And first, what I want to do is graph this just to get a visual of that on the canvas. So I'll go back to my coordinate system and put a coordinate system on here. And I will, just like we did before, drag 8x squared plus 8x plus 7 on top of it. Doesn't look like a parabola yet because I got to zoom in a little bit. There it is. And then let me shrink it this way and shrink it that way. So we have a parabola. I'm actually going to make it 3 and 3 so we can see a little bit clearer. Awesome. So now, this would be after talking with students what it means to complete the square and why we want to do that. And what we're really trying to do is like, we want to arrange the algebra tiles into a square. So there, I just use the ruler to make a couple lines. What could I do here? Let's take the x squared, and I'll take 4 of the x's over here, and these other x's I'll spin around and put those over here, and then these 1s like this. So there we go. I think I've like on my way to building a square. I'm just going to move this over so it's a little bit closer, and here was our starting thing. And what I found as a teacher, students would always do would be like, all right, I need to complete the square. Let me go to the algebra tiles. This was, I was doing it on paper at this time. I'll make this a different color just so it stands out a little bit. We'll make it purple. And they said, I'm going to fill in the square. So I'll put 1 here. I'll put a couple here to fill it in. I can copy this whole row. And there we go. I completed the square. And they thought they did it correctly. And I had a hard time explaining to them why that might not have been correct. But now I can say, all right, well, what algebraic expression have you made here? Well, they've made x squared plus 8x. We had the 7, and then we added 9. So I've made that. And if I make this bigger and a different color, so let's make it blue, and I put it onto the graph, that's not good, right? It's a different graph. It's a different representation. So it's a really nice visual that what you've done by adding this 9 did not keep it the same, right? And so what else could we do? Like we've added 9. We don't want to change the value of it, right? So I could take a 1 and a -1 and show students, right, that makes a 0 pair. So we can add as many 0 pairs as we want, as long as we make sure every number we add has a -1, that goes with it. So I could take these 8 and copy them. There's a negate button at the bottom. So if I take all of these and hit negate, it'll make it a -1. And if I negate that, there we go. Now, by doing this, I haven't changed the stuff. I've just added a bunch of 0 pairs. That doesn't change it, but I've pulled it apart. Yes, the recording will be available later. So here, what I've done is I've done 9 and then -9. And now you can see when I take that off the graph here, whoop, it's not there. But when I put it back on, it stays on top of it. It's the blue on top of the purple, right? There's the purple, there's the blue. So that's giving students good visual confirmation that what they've done has kept these the same. And now we could talk about, well, what expression do we have here? We have an x and then 4 1s, that's x plus 4. And that's the square. It's an x plus 4 square minus 9, right? So then I could say here, let me copy this and say, all right, well, what we actually have here is this is plus 16, and we've made this a square. So we have x plus 4 squared minus 9. Now, did I do that correctly? I think so, but let me take this one off and put this one on, and I hope that it goes right on top. Oh, it does. It goes right on top, right? So now it's giving me that visual confirmation that my algebraic procedures kept the value of that expression the same. And I think that's a really powerful tool for kids. Two last things to show. It is 7:51, and then I want to give time for questions. But in our task page, 2 tasks that I think are really appropriate for tonight. So now just going back to mathagon.org/tasks. One is tetromino equations. So I'm just Googling tetromino, or in the search field here, I started typing it in. I'll put the link in the chat. And this one, part of it is like a typical thing I've done in school for years. So, there's a canvas here that I'm going to open where you ask students to take a shape and, take any of these shapes and cover any 4 numbers. And they would tell me the sum of the 4 numbers, and I would know exactly what 4 numbers they covered. And it was a really nice kind of magic trick. And then we went through the algebra and talked about how I was able to figure out, what their numbers were. And you can go and explore that on their own. If you don't want a spoiler, don't look on the screen here. But there is, some algebraic rules here of like, if it's like this, this is n, this is n minus 1, n plus 9, n plus 10. So the algebraic rule there is 4n plus 18. So you can go through that number grid and find the rules of all those. But what the rest of this activity talks about is what happens if you expand the grid. What happens on this shape if instead of a 10 by 10 grid, it's a 6 by 10 grid or a 16 by 10 grid? Can students find the general rule of what these numbers are going to cover on any size grid, right? So here, if I put that on here, I can extend the grid right on the canvas. As I change this black handle, what's happening to the numbers that are covered by that shape? Can we find an even more general algebraic rule that for any size grid, there's a way to find the sum of those, right? And that, talk about low floor, high ceiling for students to really extend that up another level and say, oh, great, you got it in a 10 by 10 grid. That's awesome. Take this handle, make any grid you want, right? Kids could make a huge grid and find a rule on that one, right? And go down. Obviously, when I'm going down, not much is changing, right? But extending the grid across really changes things. I think that's a really fun activity for students to explore. All right, I, as always, talk too much, but a few shout outs and then questions before we go. Again, a few links, mathagon.org/tasks has all these lesson plans. If you go to mathagon.org/teachers, there are events and webinars, including this one will be up within a couple of days. You can go learn here. If you want to register for future events, I encourage you to do so. Thanks for coming tonight. Here's the one tonight. We have a number of guest speakers coming over the course of this school year. Mary Kemper, Maria Del Rosario Zavala, Dan Finkel, Katronia Ag, Desiree Harrison, and Jennifer Saw. And within a couple weeks, we're going to be adding our Mathagon webinar schedule for the rest of the school year. So you can see in December, we're having one on how Polypad was developed, all the mathematics behind the coding of Polypad, which would be fun to learn about. And our guest speaker series is scheduled for the year, but we're also going to have a number of like tutorial webinars over the course of the 2022 as well. So come back and check those out. Before we open it up to questions, Dr. Nikki Newton, anything to add or closing? You were supposed to interrupt me more and jump in like I did.
Yeah.
Just sat there quietly the whole time, letting me.
No, it was amazing. It was amazing. It was amazing.
Awesome. Well, thank you all for joining. Well, I will happily stay on and answer any questions that you have. This will end the formal presentation. Yeah, there's just like a shout out there for following folks on Twitter. If you want to drop your Twitter handle in the chat, and maybe people will give you a follow before they hop on off. I'm at David Porras, Dr. Nikki Newton. I don't know yours off the top of my head, but drop it in the chat. Feel free to put yours in there, everyone. I've learned a lot from folks over the years on
Dr. Nikki Math. I think it's at Dr. Nikki Math.
Awesome. All right, I'm going to scroll through the questions. Thank you, everyone. You're welcome, of course, to stay and listen.
Thank you for coming.